Let us discuss about the application of trigonometric ratios of angle 45. In this case, we will discuss about the application of those ratios to solve distance problems. Look at this picture here. This is a tree in which, let us assume that you know that this line makes with the ground angle 45, and this line runs from the ground to the peak of this tree. Along the tree there is this line which is vertical and perpendicular to the ground, and the distance from the bottom of the tree to this point here is 5 meters. So the ground distance is known, but let us assume that you would like to get this height here, the height of the tree. In fact, you want to get the height of the tree without actually measuring the height along this tree. So what you do is to construct the triangle, and the triangle will be this way. This angle here is 45, this is 90, and this is what is the height of the tree. Let us call the height of the tree to be h. And this distance, which is ground distance, is 5 meters. With this abbreviation, we can reason out which is the appropriate trig ratio to be used to determine this height. Looking up in this triangle here, this is the opposite and this is the adjacent. Opposite and adjacent makes the tangent ratio. So we're going to use the tangent ratio, which is tangent of 45 degrees, which is opposite h over the adjacent 5 meters. We're going to use this ratio to determine this height here. In this case, we do not have this tangent of angle 45. So what do is to find the tangent of angle 45, and later we'll find h. How do we find it? We apply this right triangle, in which this side is 1 unit and this is 1 unit, and this angle here is 45 and this angle here is 45. So in order to find the ratios for this triangle, we should find all the sides of this triangle. So you may call this side x, and then you apply the Pythagoras theorem, where the square of the sum of squares of two adjacent sides will be equal to the sum to the square of the hypotenuse. So in this case, this is going to be 1 plus 1 equals to x squared, and this is 2 equals to x squared. Then you square both sides, you get square root of 2 equals to x. So this distance here is square root of 2. And then now it is when now you can find the tangent of 45. Remember, tangent is opposite over adjacent. So we would like to find the tangent of angle 45 here. So let us take this angle here. Opposite over adjacent. The opposite is 1 and the adjacent is 1. So tangent of angle 45 is 1 over 1, which equals to 1. Remember, we had this. Tangent of 45 equals to h over 5 meters. So we replace this one with 1 equals to h over 1 over 5 meters. and then you place this over 1, you do, and then you do cross multiplication. You will end up getting h equals to 1 times 5 meters, which is h equals to 5 meters. H is obtained by taking h times 1, which is h, and 1 times 5 meters is 5 meters. So this is height of the tree. I hope this short video will help you to apply the trigonometric ratios of the special angle 45 to solve distance or height problems.